Nevada Virtual Academy, we are back again, back in business. Let's do some math, let's do some proficiency exam problem. Algebra all over the place. Problem number 170. The graph below shows the amount of money in one of Marie's savings account over several years. If Marie's savings continue to grow at the same rate as shown in the graph, how much money will she have saved by year 5 in this account? Okay, and obviously that year 5 is missing here, right? Well, sometimes you can just extend this and try to guess, right? Especially if you have a multiple choice type of answer, you may get, hey, 5, the year 5 is going to be here somewhere, right? Try to go with the straight line. And that would be over here somewhere, in which if I'm going with an horizontal line will intersect my vertical axis, my savings axis, saving amount here, which is between 2500 and 2600. Obviously, there will be some error there. I suppose will be around 25, let's say 50. Do you have that option there? It was like I had 2531 and 2553. So you see, you can eliminate C and D, but you're still stuck because you need a more precise estimate in regard to the answer here. What I can say is probably the answer is going to be 2553, but we don't know that yet, or let's assume we don't know that yet, and find a way in which we can figure it out. Well, how about making a t-table and calling this y-axis y and the other one x, right? My pen is not writing. Okay, good. X, the inputs, y, the outputs. Okay? Inputs given by year. Year 0, as you can see, we have a 0 year where basically her savings were $2,000. Second year, well, it's not second year, it's the first year, right? After 1 year, we may call it. We got how much money, or she's got how much money in that account? $2,100. After 2 years, Marie's got $2,205. Okay. After 3 years, Marie's got $2,315 bucks, right? And after 4 years, Marie's got 2,431. All right. Now, if this is a linear equation here, you boys and girls remember that that equation will look like y equals mx plus a number b, okay? Where m is going to be your slope, right? Slope is given to you by rise over run, or if you want to say by the change in y over change in x. When I'm saying that, I mean y2 minus y1 over x2 minus x1. I hope you can see that. At least you can hear me saying it, right? Good. How about b? How can we find b? Well, an easy way to find b is by making your x here 0. And when that x equals 0, we know what the value of your y is. Y will equal 2,000, right? So I will have 2,000 equals my slope times 0, right? Plus b, but this number here is 0. So what is my b? B equals 2,000. Which says that my equation is actually of this form: mx, slope times x, plus 2,000. How about finding the slope? If I can find the slope, I will be done, right? How can we find the slope? Well, like I said, slope is the change in y over change in x. And let's see if we have a constant change in here, or if we can approximate that. If not, we may not be able to find exactly what the slope is, but we may find an approximation of that. Okay, let's see what is the change in x. Well, x changes from 0 to 1 will be positive 1. 1 to 2, positive 1. 2 to 3, positive 1. Right? So it looks like my slope, my change in x is a constant 1. Good. Let's see what is the change in y. From 2000 to 2100, I have positive 100, right? From 100 to 205 here, from 2100 to 2205, I have positive 105, right? From this one, 2205 to 2315, I have a difference, a positive one of 110, right? To the next one, I have from 2315 to 2431, I have a difference of 116. Okay, so it looks like my change in y is going from 100 to 116, and if you want, we can make the average. We can find the average of that to find, you know, what is the best slope, what is the line of best fit for this points in here, imagining they're not on a straight line, and they probably not, you know, they cannot, they should not be on the straight line. This is just a plot. We're trying to find the line of best fit, the line that best approximate all this data set. To find that, let's add all these differences in y, and I have what? 100 plus 105 plus 110 plus 116, right? Add them up. I got 5 plus 6, 11, right? 1 plus 1 plus 1 is going to be 3. 1 plus 1 plus 1 plus 1 is going to be 431 divided by 4. And we get approximately what? 4 goes in 4 once. 4 goes in 3. How many times? 0 times. But in 31 goes approximately 8 times. Okay, I'm going to use 108. So I can move on and try to approximate the slope. The best slope for a line that will be, you know, the best fit for this given, you know, points here for this plot will be what? The change in y, which we said is approximately 108 divided by the change in x. The change in x is a constant 1. Okay? And let's plug that in back into my equation, because this 108 over 1 is actually 108. So it seems to be that the equation for this line, the best approximation of that equation, right? The best line will be y equals 108 times x plus 2000. Okay? Well, what is x for the fifth year? The fifth year is going to be there. X will be 5. Okay, so I will say if x equals 5, then the saving amount, my y, right, because this is the savings axis, will be 108 times 5 plus 2000, which equals what? 108 times 5 will be 540 plus 2000. And the answer will be 2540, right? And remember, this is an approximation. Well, this is the closest one to what? To 2531 or to 2553, right? And I got 2540. From 2540 to 31, I have to go down how many units? 19, right? Minus 19. From this one to the other ones, the 553, I have to go up 13 units. And this is the closest one, the best approximation. And that will be the answer to the given problem. We are done.